So this week we're going to cover using structs. It's been a while since I've looked at this, so hopefully I roughly remember what's going on. So yeah, there's tuples and structs, and they're pretty much the same thing. One has fields, and the other doesn't. Is it tuple or tuple?
You're asking the wrong answer.
You don't answer away?
I've always said tuple, but I don't know. Just how I was taught it.
Cool, it's probably tuple then. Zero education on this one. So I forgot to look like that. Yeah, this isn't a particularly exciting example. The structs give us the ability to have something similar to classes, I guess. But yeah, store data as fields, and I guess similar to like JavaScript objects, but everything is strongly typed. So you construct a user like this, and let's just try and run that. Semicolon. Cool. So yeah, it immediately then complains about the lack of all the fields, which we should put in. Okay. Yeah, that compiles. Don't really have much else to say about that. Is there anything distinct about this? I think, like I say, the only thing I can think of is obviously it complains when there's lack of fields, which is quite different to most languages that I know. Yeah, which I believe we covered a time ago, and obviously way ahead of time. Removed. Obviously, that gives us the default implementation, which even if we do this, still won't compile.
Yeah, you've derived debug, not default.
True, thank you. But it still won't work, right? It won't work at all, right? Yeah. How you do? Yeah. So derived default gives us the default implementation of default, which is a function. But we're using this. But anyway, it adds a method onto user called default. And for all these basic types, the trait is implemented on those individual fields, and it fills them in with the default implementation, which I believe here would be false. Let's just try and do that. Just going to complain because I don't have default. Oops. how to write Rust in a week. Yeah, so you can see that active is false by default. So you could derive that yourself, which we could do if you want.
As in derive it for user.
Yeah, so you can actually write it yourself. Hang on. Let's keep the book so I can print that.
Why do you need debug for printout again?
So this colon question mark is debug output, because on its own it doesn't really mean anything. So if we didn't derive debug, this wouldn't work, and if we got rid of that, that would be display output, and neither are implemented for the struct by default.
Right. Okay.
Yeah, so display is more like what you would use in a real world application, I guess. Whereas debug is like, hey, just tell me what's going on here. And neither really is derived by default.
So it's like having two separate two-string functions in, say, like JavaScript or whatever.
Yeah, exactly. Yeah. And neither are given to you by default, but you have this derived debug, which works out of the box.
Yeah.
So then we need to implement the function debug. I'm just going to add that there because I don't actually remember. It needs to output itself. Does it? No, it needs to output a string. Okay. So
I think you mixed up default and debug again.
Okay. So they expected a user and not string.
Oh, right. You're supposed to return a default user.
Yeah.
Whereas with debug, you're returning a string.
So again, I mixed them
Yeah, you
both
mixed
up
them
completely. You know, like, yeah, all right. Cool. So let's just copy these because I'm lazy. That was useful. So let's set this as true by default. So, you know, when we create a user, sign-in count 0, email address, let's just make it blank string, which would be the default for a string, I believe. And again, blank string. And it wants them to be strings. So, why is it not? Yeah, Rust is important that we make everything the same type, as we find, which is pretty expected. I'm just an idiot. And yes, now the active is true rather than false, which was the default implementation, not debug. Okay.
So can you?
Go
I don't know if we'll get to this, but like, what about things you don't want to have defaults for? Force people to. Because right now you could, instead of username at the bottom when you're inside of your main, instead of username, you could just do default. But what if you wanted someone to always put a username?
Like a partial implementation. I don't know if that's possible. Yeah.
Okay.
Not that I know of. I mean, you could probably do it with a like half of that in a different child struct, maybe. Because like this can be a struct, right? Like, so you can have structs within structs within structs. So you could just store the bits that I guess are a bit more mundane and like login count and stuff like that as its own struct. Give it as a default for that, and then these two like require an implementation, I guess. But I don't think there's like here's half your functions. Like you can do for like traits and things. You can give like half the functions or whatever ones. Okay, so yeah, they've pretty much done what we've done. And yeah, so fields are mutable by default when the whole struct is mutable. Obviously, but let's just run this just for. Let's keep on going. Oh yeah, that'll mutate user one to be what we expected. Although I removed the definition of user, which isn't useful. Right. But if we remove the mutability here, obviously that's not going to combine. Yeah. So the standard like mutability errors that we get from normal lets, we get for the fields with them. Okay, so I guess this is just making as a default field user, passing in two arguments. Yeah, so I mean, I'm not printing it out, but do that anyway, because it doesn't implement this flavor. Yeah, so that's what I was saying earlier. We can't do that, and we can't do this either. Oh wait, what? Oh, we defined it.
Yeah.
Yeah. All right. Cool. Yeah. So this is basically the same as what we were doing before, but through a function.
Which could be a way to do partial.
Yeah. So I guess what they're going to cover next is that you could put that as. All right. Yeah. There's also shorthands as well, which is nice. So that's a bit like JavaScript again, isn't it? Okay, so we've kind of covered this already, but let's do it again. So we wanted to do a let user to. And just specify a username. We can take the fields of user one and push them into user two like that. Yeah. Yeah. Basic error again. So we took in the, I did it the wrong way around, but you get the picture anyway. I copied in the email, the signing count and the actives.
It's the same thing that happens when you use default, because I guess default is a function that returns.
A user, yeah. So it's,
It's actually the same thing.
do they call it destructuring? Assuming. Not destructuring. I don't know.
Constructed.
You know about destructuring in JavaScript?
Yeah, because I mean, essentially that's what this is, right?
Sort of. If you were
Um,
to do that in JavaScript, user one would completely overwrite everything that's already done. Because in JavaScript, you can have a partial and then destructure that into what's already there.
yeah, so that's what we're doing here.
Yeah, but I'm saying user one would completely overwrite user one as well.
So you'd have to
So
set
you
username.
dot user one and then specify username afterwards, and I think the
Yeah,
username
yeah,
it has to be the other way around.
Oh, I see.
Yeah.
Whereas Rust doesn't care. I thought it was possible that way. I thought it was smart enough to. Maybe I'm just so used to Rust now. I'm like,
It's not
Yeah,
sure
it
whether
was
the
like
order
JavaScript.
affects the priorities or not.
Out of interest, what happens if you swap those around in Rust?
I think it's just smart enough because it's just like, well, these fields weren't there.
Oh, you should specify that explicitly.
It's making it multiple users or no?
Remove
Comma
the
at
column.
the end. At the
Or
end.
maybe it's not possible
No, the one at the end of username.
No, they didn't talk about that.
Rust doesn't mind covers at the end of lists.
then. Yeah, so
Lists.
So when you have a list of things separated by commas, Rust doesn't mind having an extra one at the end.
Oh, does it not?
I think the logic is that it makes your diffs cleaner because when you add something to the list, you don't have to make any changes to the lines above and below it.
Right. Okay.
yeah, I get told off by that on my divs all the time. But yeah, apparently it's not possible. So always at the end, I guess. Which is easier to read, I think, rather than the other way around. So I guess there's, yeah. So yeah, fields, like I said earlier, is basically the same thing, just you don't name the fields. But yeah, they behave the same. So kind of nice, I guess, when you're writing like a function that has a fairly obvious interface, like point to whatever and calls. But other than that, I don't really know that much use of them. I think they're good as like shorthand, like return values. But yeah, you can like use them the same. So you can do import, color, and add methods here. Apparently got time again. Cool. Yeah, so this function just returns this value by this struct. So you just index them numerically rather than by name. Yeah, so the most common one is the unit type, which you get from everything. Okay, so yeah, a bit about boring. You can specify lifetimes on the struct, but we're not cutting that.
We've got references inside of the struct.
Yeah, so if you wanted the struct itself just to borrow the data rather than own it itself, then essentially the struct itself needs to have its own lifetimes that outlive this str.
Right. If you're
Sorry, the str needs to outlive the
Yeah, of course.
struct itself. So the contained field never gets dropped before the struct itself gets dropped.
And presumably that's something that the checker
Yeah, so you would like specify the lifetime here and then like annotate this lifetime and annotate the other lifetime. The checker would make sure that when those strings drop here, that this itself is dropped like before. But yeah, that's basically what it's complaining about, like dropped references. Whereas in C++, that would just break.
You just get technically.
Yeah, that great error that you have. All right, and move on to the next chapter. Oh, I see. Sorry, I was like, there's no struct in this. This is like an example to prove that structs are useful, I guess. Okay. So yeah, some basic maths. To call a function, the function returns u32, and then we go together. But I guess obviously that doesn't have any meaning on it. Yeah. So like this situation, you could obviously mix these two up, and wouldn't be a problem in this math, obviously, but yeah, it would be a problem in the bigger thing. Okay, so they're going to use tuples, which doesn't make much sense, but I guess that should be what they do. So yeah, like before, they just index references into two fields. Bit too big. But nothing on objects, right?
I guess it also you could use it. It also have like width and height the structs on their own. Or I guess in this case it would be tuples of one number each. Could you do that?
Yeah, and so you can, yeah, you do see this in like quite strongly typed code where you have like,
It's strongly typed, but also easy to use in a sense because when you construct it, it's just width and then number in between, which is also quite self-explanatory.
yeah. I would say makes the type signature a lot neater, right? Anyway, no, function itself. But I guess that makes it.
Oh, but you still have to do width dot zero, don't you?
Yeah. I think so, yeah.
And height dot zero as well.
Right. That was off. Yeah. Semicolon, always.
Oh, it needs to be named differently to the struct.
The name of the variable.
Yeah.
Because it can't tell the type. It can't tell the type.
Oh, that's a shame.
But I also need to pass them in as well. Is it done?
Oh, same thing, I think. the function area has width and width. What you want is like W and H instead of width and width, I guess. No, that's the type, isn't it?
Yeah.
Oh yeah, sorry. Yeah, but other way around. Yeah.
But yeah.
I've never seen much combined like that. Only. I guess I don't use these right. Alright, yeah, we got the right result, but
If you remove the dot zeros on the end of the width A and pi A, does it still complain?
I would expect.
Because surely it just assumes you're accessing the one variable it has, right?
but we could import that to then look at.
Oh,
It's a pain.
because the whole point of me saying that is because I thought it would make it really easy to have strongly typed code if creating and using a struct that just had one number in it was really simple. Because then, you could have your code have things like width and height as types.
See, that's something that I really like about Haskell at the minute. You can actually do it's kind of like a type def, except it means a completely new type. Well, a name for that type, right?
Unless there's a way that I am specifying this wrong, because this is actually like called the new type specified, like what you're saying, but
Yeah.
like you say, it's also not very useful.
So something that looks like there's a crate called derive more, which does let you write hash derive mul and hash derive add.
Just by default.
Yes. Using some magic macros, I assume.
Yeah, use prompt macros probably. Yeah, I don't know how to define this, so. Oh, needs until. You get that too.
Because you haven't put the type after import more.
Oh wait, sorry. Right hand side is a generic, I think. So it's like RHS equals width,
Oh, right.
maybe. I mean, yeah, I've never tried to implement mul before, but it's roughly like that. Not trying to waste it. So. Oh, press back. Where were we? We got to like here, I think. Okay. Yeah, so this is the area that we saw earlier, where trying to print out the rectangle doesn't work because it doesn't do the right display. So you get this horrible error. Not horrible, fairly nice error. Yeah, so we have to derive display. Yeah, try using that, which it doesn't like that either. But it gives you the help. So we've already done that. Yeah, so we've seen it already.
So if you derive debug, but then build a release build, the print line still works.
Yeah, I think it's just so you can like be clear that this is debug rather than. So like I don't know, like if you were connected to a database, obviously you wouldn't try and like. Yeah, like you can make it more like debug friendly. It's like really verbose versus like your display output is more. I'm a user. So,
I guess what I was thinking is it isn't affected by the state of the build that you're trying to make.
No.
So you could still have debug-like logs in.
Yeah, as soon as like console.debug.
Yeah. Yeah, if you wanted to have, if you were using a logger and you wanted to log in debug, as long as it's got derived debug on it, it would still work, and you would still get the debug output instead of the display output.
Yeah, I think so. Yeah, it's not. I think it's maybe a confusing name in that sense.
Yeah.
I don't think it's like that. Yeah, I think it's for all contexts, but you might not necessarily want it in your release build, but it's not flagged off or anything. I don't know what hash is, do you?
It looks like it just makes it print each thing on a separate line instead of putting everything on one line.
Oh, I see. Yeah, like pretty print debug. And then, is that a different trait? Or is it just that it decides to do it?
Because like one of the formatter things that the print line does, or whatever the formatter it uses.
Let's try. How do you want? Yeah.
Yeah.
Yeah, so I guess, I guess it just worked out. I don't really know how.
Yeah. They're probably like a standard formatter that it uses.
Yeah, I don't know. Because this is just like a string, so, and the other thing's just returned it as one line, so I guess it, I don't know, decides to put new lines after braces maybe, and then indents everything. Cool. Yeah, so Rust gives us a load of traits. We'll cover those while. Yeah. So then they say that they're going to move the area function into something on the actual struct itself. Yeah. So we've kind of covered this already with the impl trait, but it's just specific for the struct itself. But obviously that makes it a lot more readable, right? Having like separate functions lying around everywhere. Yeah. So you specifically asking the rectangle what the size is compared to these fields. Yeah, so the one thing to note, I guess, is that you're using and self rather than just self. When you use just self on its own, it consumes the value. So if we try and do that.
You basically owned it, or I guess transferred ownership into the area, and then once
Yeah, into its own method. So if we learn to type and then print it out, have we got debug? Use a new fancy formatter and use rect1 again. Yeah, so it's complaining that we've consumed the value within the area and then we've tried to use it again. So the normal borrowing rules apply when something takes ownership of it. We're never passing it back, we're just passing it back a U32 computed. So this has consumed our rectangle at this point. And so when we try and print it out, the compiler throws it. Obviously, it's more conventional that you see that in these functions.
And of course, that's immutable by default.
Yeah, so the alternative would be this, where the compiler is going to say, you didn't really need me, but well, you also need to be mutable. Well, that's weird. I was expecting a compiler warning then, saying that I didn't really need. But that's fairly self-explanatory, I guess. Just need to own it, and then you can mute it. Yeah, so I guess, yeah, you don't have to type out rectangle every time, you just type self. That's an advantage. But I guess it makes it more readable that you know that it's representative. Yeah. Yeah, so obviously C++ is different here. To use the arrow function. Yeah, I can never remember these.
It's the arrow if it's a pointer.
Yeah.
Or dot if it's actual object.
Yeah. But they still have the colon as well, right? For the static methods as well. So
Yeah.
Yeah. Obviously Rust has that, but yeah. Which we haven't actually covered, but because you can have
Associated method.
yeah.
It doesn't take self enough for it to figure out.
Yeah.
Yeah.
I guess this is another answer to your default implementation, isn't it? So you can create yourself a new Rex by just doing. So obviously it doesn't take any state, it just builds it itself. But it doesn't really have to return rectangle either, it could just be, yeah. I guess this is just an namespace, so you don't even have to consume a rectangle and you don't have to output one either. Just relevant functions, I guess. But yeah, like you're saying, pointers versus references. Still. That's nice you wanted to cover that.
No.
My C++ is worse than Rust.
Implementing a method inside of a rectangle.
Oh, I see. Yeah. So can it hold? Yeah, I was confused because there's no implementation.
Yeah.
So,
I think that's what it's supposed to be.
so yeah, they're taking rectangle as a reference. Let's just copy this. So they're taking another rectangle by reference, so they're not consuming that volume, so they can use it later on. Well, we're not actually seeing that here, but yeah, you still pass back rectangle 2 after this is finished because you're not consuming. Yeah, and so we're looking at each of the fields. So fields are public by default. Yeah. Yeah, and associated functions, which we've already covered. Yeah, you can, I guess, yeah, take any arguments and return whatever arguments again, but you reference it with the co-op syntax. Yeah. Yeah, you're not limited by one impl block, which I don't know, I think it's a bit bizarre, but handy, especially in code generation.
It lets you extend classes that you already have.
Well, yeah, but just specifically for impl, I think in the default sense is a bit weird, is it not?
So just explain, there's more about this in chapter 10, where it shows how it's useful for generics, where I think you can say implement extra methods if the type parameter happens to implement this trait as well.
Right, yeah.
So you can have methods that only exist if it's possible to support them, but it's okay to have types that don't support them.
I see. Yeah, so I guess it makes more sense for that, but like this, I'm kind of surprised it actually supports, to be honest. But like I say, I've come across this before where like you're doing a for loop and you're implementing functions and you just want to throw out a function per loop, I guess. But that's my use case, but I guess someone else has got some others.
Oh, wait, is it, if you do that impl inside of the, if you do the impl inside of a function, it's not limited to that function. Like you've added that, you've added whatever
No.
you've added to rectangle forever. It's not limited to the scope.
I don't think so, but I think that's what we were talking about
Right.
for traits, which is weird. Was it you, Gail? Or was it Matthew?
But still, I don't think you're allowed to have impl blocks inside functions.
Yeah, you can, yeah. I was specifically on about like code generation where like it runs first and that. Yeah, you might just like rather than trying to like munge together the output, you might just output it here and then output it over there. But yeah, I guess. But yeah, we can do that in main, like struct. And it doesn't know about those fields, so let's just delete those. Love type completion. Yeah, so that should work. Got rid of the rounded. Yeah. So the implementation is specifically to the scope, I think.
Okay, so if you were to create another scope,
Another function. Oh yeah, I'm just doing
just create another scope inside of main,
Yeah.
and put impl thing inside it, and put a print line inside and a print line outside.
I think that's worked well at this point. Yeah, that should do it.
Oh yeah, we could just do that.
Oh, okay. Maybe it does escape scope.
So it permanently adds it to the
Yeah.
to thing. Doesn't care where it was defined. It just adds the function to thing.
Let me just put it here. Okay. So I guess, yeah. I thought that was only for traits, not for import. That's particularly horrible. Okay. Good to know. Oh. Yeah. Interesting.